Alright, so I'm going to help you with solving limiting reactant and percent compositions. So the first part of the homework is balancing. You know how to do that, so I'm not going to go through that again. Alright, up here in the corner I posted the roadmap, so we'll refer to that when we need it. So anyway, first problem just asks you to find limiting reactant. So remember, the strategy for finding limiting reactant is moles that you have divided by moles that you need. So that's the formula for and really what this is right here is the coefficient. Okay, so that's the coefficient. So if we look at this problem right here, we have 4.20 moles of aluminum, and we need 2 moles of aluminum. So our ratio is 1 to 2.1, or 2.1 to 1. We have 1.75 moles iron 3 oxide, and we only need 1 mole, so 1.75. So this right here is my limiting, because it's a smaller ratio number. Anyway, so that's how you do limiting reactant. It's pretty easy. Then you calculate the mass of iron in grams. So I'll use my limiting reactant. I'll do my mole ratio here. I want to find iron, and I want to get rid of the iron 3 oxide. Remember, I got that 2 for the iron up here, the 1 for the iron 3 oxide right there, and then I multiply those across. I get 3.5 mole, 50 mole of the iron, and I multiply that by the molar mass of iron. That's 55.85 grams, and then I get 195 grams of Fe. So that's how you do that. And then my HAL here, so my HAL here would be in excess. Okay, so if it's not the limiting reactant, it's in excess. So by the way, if you're looking at your roadmap here, so my start was here, and my finish is there. Okay, so if we're keeping track of that, that's what it was. All right, I'll help you with the next one if you like. Let me get a fine point, probably work better. So the next one's a different type of equation. So it asks us a bunch of different stuff. First, you have to balance the equation. So in the equation, I have silver nitrate. Right, I have iron 3 chloride. I have silver chloride, and I have iron 3. Oops, that doesn't have a 3 on it right there. It's just iron 3. Iron 3 nitrate. Okay, so if I want to balance this, I'll notice I have 3 chlorides here, so I put a 3 here. I have 3 nitrates there. So I'll put a 3 there, and that should be balanced now. Okay, so moles of each reactant you have to do first. I start out with 18.0 grams silver nitrate. So I've got to go to moles for that. I calculate the molar mass. I get 169.88 grams. Got that from the periodic table. I I get 0.106 moles. Over here I have 32.4 grams of iron chloride, or iron 3 chloride. And the molar mass of that was 162.20 grams. And then multiply that out, I get 1.75 moles. Then I can just simply figure out my ratios for my limiting reactant. So here I got 0.106, and down here I had the point. I wrote down the wrong number here, so I apologize for that. This was 0.199 moles. Okay, so I have that. My coefficient for iron 3 is 1. Oops, my coefficient for silver nitrate was 3. I get 0.0353, and I get 0.199. So that would be my limiting reactant, which is the silver nitrate. Okay, so that's the first part of that. The second part, it says calculate how much excess reagent was used. So remember, if my silver nitrate is limiting, then my iron chloride is excess. So I'll come over here and we'll start with my limiting reactant, which was my silver nitrate. So I have 0.106 moles. I have to do one of these because I've got to go see how much iron 3 I'm going to use. Right, so remember the coefficient with that was 1, this was 3. So when I divide those out, I get I get 0.0353 moles. I got to multiply that by the molar mass, which I already calculated before. And from that I get 5.73 grams. Okay. All right, so I'm going to use this here. That's how much of the iron 3 chloride I used. Remember I told you started with, I'm looking at my notes here, 32.4 grams. All right, so that's how much you started with, and you used 5.73 grams. So the amount of excess you have left is 26.7 grams of iron 3 chloride. So I have that much remaining. Okay, so that's how you do those problems. All right, last one I'll help you with, and number 5 you'll be on your own. All right, so this is theoretical yield and percent yield. Okay. All right, I have my balanced equation up here. All right, so that's my balanced equation. It's already balanced for you. So first thing I have to do is calculate the theoretical yield. So experiment has begun with 75.00 grams of barium nitrate and an excess. So it already tells you what the excess reagent is. So the barium nitrate must be limiting. So I can start here. So I can start with my barium nitrate. I got to go to moles, remember. When I calculate my molar mass from the periodic table, I get 261.2 0.35 grams. And so I do that, I get 0.2870 moles. Barium nitrate. Now from there, don't have a whole lot of room. I'm going to go to barium sulfate. I'll get rid of the barium nitrate. All right, so I end up with the same moles because it's a 1-to-1 ratio. All right, and that's the barium sulfate. So right now I'm going to multiply it by the molar mass, which is 233.40 grams. Again, I got that from the periodic table, and I get a theoretical yield of 66 of 99 grams of barium sulfate. All right, so that's how we did it, just straight stoichiometry. All right, we started at mass, went mass to mole, then mole to mole, and mole to mass, if you're going back up to your roadmap there. All right, for theoretical yield, remember, for theoretical yield, or for percent yield, it's actual, which is the same thing as experimental, divided by theoretical. Okay, so it tells you up in here, after collecting and drying the product, so this right here, right, is the actual that you got. So we'll take that, we'll put it here, 60, oops, that doesn't go there, does it? Yeah, it does. 63.45 grams. And then my theoretical goes on the bottom. When I calculate that out, I get 0.9472, or 94.72%. Okay, so that's how to solve all the problems. Number 5, you can solve on your own by looking at what you did above. So good luck, and I'll talk to you soon.